Welcome. In this video, I'm going to demonstrate how to find or how to compute the arc length of a parametrically defined curve. Here we can see the x-coordinate and the y-coordinates definition when its parameter t varies from 0 to 1. Now, before we begin, recall that arc length is computed by integrating from the lower bound to the upper bound of the values for the parameter. And then we have the square root of the definition of the x-coordinate, squared, its derivative, plus the derivative of the y-coordinate squared with respect to the parameter. All right, so let's go ahead and set up our integral. Well, dx over dt, that's just x prime of t, and that's 6t. dy over dt is y prime of t, and that's 8t. So we have the integral from 0 to 1 of the square root of 6t quantity squared plus 8t quantity squared dt. This yields the integral from 0 to 1 of the square root of 36t squared plus 48t squared dt. Continuing, we can simplify this algebraically to the square root of 100t squared dt. So this is 10 times the integral from 0 to 1. And I'm just using t, not negative t, since t is from 0 to 1. So t won't take on any negative value. So we have 10 times t squared over 2 from 0 to 1, or just 5 times 1 squared minus 0 squared, or just 5. So there is our arc length. I hope you found the video helpful.